Lesson 10.5, probability and the addition rule. First thing you guys got to know about is what does it mean if something's mutually exclusive or not mutually exclusive, like two events. And a good example is, let's say you pulled some cards out of a deck. Okay? Now, could you draw both a card that was both a jack and a king? Well, no, you could not do that because there's not a king jack card. So you could draw maybe a jack could go in this bubble and a king could go in this bubble. And there's of course other cards you could also draw that are either jack or king, but you couldn't draw a card that was both a king and jack. But what if I change the premise to a king and a diamond, right? Now there are cards that are kings that are not diamonds. There's uh, kings that okay, kings that are not diamonds. There's diamonds that are not kings. Okay, but there is a king of diamonds. Okay? So there's now some overlap. So Jack and King, mutually exclusive. You can't have both at the same time. King and Diamond, ooh, you can have both at the same time. In fact, you're looking at it right here. That's where these bubbles would overlap. So what's this math notation I jotted down here? Oh, okay. So if two events are mutually exclusive, right, so there's no overlap, then the probability of A or B, remember that union right there means or, that union is or, okay? It's very simple. You just add the probabilities of those independent events together. Okay? So probability of drawing a jack, 4 out of 52. Probability of drawing a king, 4 out of 52. Probability of drawing either a jack or a king, well, 4 and 4 would be 8 out of 52. Okay? But if I switch to something like probability of um, let's say a diamond or a king, you say, okay, well, I know there's 13 diamonds, right? So probability of diamonds being 13 out of 52. Probability of king, well, there's four of those, so 4 out of 52. But there's some overlap. There is a single card that's both a king and a diamond, so I have to subtract that out because I don't want to double count it. Right? You guys see that? So if events are not mutually exclusive, there's some overlap, then the probability of one or the other happening is you can add the probability of A and the probability of B, but you have to subtract the overlap. And okay, and that's what this intersection is, right? Probability of A and B, or in my case, the king and the diamond, because there's one of those cards. So I have to subtract that out so I'm not double counting it. Okay. All right, so there's a quick rundown. All right, let's look into the examples. All right, so first example, identify mutually exclusive events. Okay, hey, we start out the cards. Great. Card example. We got a standard deck of 52 cards. Determine whether the events are mutually exclusive or not mutually exclusive. Explain your reason. Okay. Drawing a three or a two. Well, if you draw a three, it's not a two, and a two is not a three. So I would say that those are mutually exclusive. Mutually exclusive. Okay. Drawing a seven or a red card. Ooh. Now there are sevens that are red, there are sevens that are not red. There are red cards that are seven, there are red cards that are not seven. That sounds more like where'd it go? Um, okay, would be this right here. So it'd be not mutually exclusive. Okay, so three and two mutually exclusive. Seven and red, ooh, not mutually exclusive because there is a seven red card. In fact, there are two seven red cards. Okay, so there's some overlap between the sevens and the reds. Okay, how about queen or spade? I think that would also be not mutually exclusive because there is a queen of spades, and there are queens that are not spades, and there are spades that are not queens, and of course there are other cards that are neither queen nor spade. Okay, but there's some overlap. So I would say queen spade would be also not mutually exclusive. There you go. Okay. Um, hmm, okay. Example two, probability of mutually exclusive events. Okay, so example one was just identifying, right? But now we're going to apply some numbers. Maybe I should go back to example one and just apply the numbers anyway. Okay, so 1A, drawing a 3 or a 2. Now, probability of drawing a 3 is 4 out of 52 cards. Probability of drawing a 2 is also 4 out of 52. Okay, so add those together. Probability of a 3 or a 2 would be 8 out of 52. Okay, be like that. Mutually exclusive. Okay. Um, how about this one where it said a 7 or a red? So probability of a 7, well, there are four sevens out of the deck of 52. Probability of red, I know there are 13 red, no, that's not right. There are 26 red cards out of 52. That seats. Okay. So probability of 7 or a red, okay. Well, I could say probability of 7 is 4 out of 52. Probability of red is 26 out of 52. But there are a couple of cards that are both southern and red. It's the diamonds and the hearts. So I have to subtract those out. So it's 2 out of 52. Subtract that. Right, and that could be, what's that? I think that's 28, isn't it? 52. Yeah. Of course, both of these examples I've done so far, you could also reduce this fractions or simplify or get percentages or whatnot if you like. Right. Example C, queen or spade. So probability of queen is 4 out of 52. Probability of spade. There's my 13 out of 52. Okay. Probability of queen or spade. I got my 4 out of 52 plus 13 out of 52, but I have to subtract the spade queen. So there's one of those, 1 out of 52. So that brings me to, I think that's 16 out of 52. And again, you could reduce that, but just to give the idea. All right, so there's the probabilities attached to that first example, which I think is where they're headed right here anyway. What's the probability of mutually exclusive events? And social media, what's going on here? We got Daniel organizes all his social media contacts into 3 groups. Oh, maybe it's these 3 right here. Close friends, acquaintances, restricted. If the program sends an update, sends Daniel an update from a randomly chosen contact, what is the probability that the contact is either a close friend or an acquaintance? Now, those do sound like mutually, oh yeah, it says right here, mutually exclusive events, which means I think we can very simply add those together. So let's do 68 plus 24 divided by, well, all of them. Right. Actually, no, they did it. They went ahead and showed it to you right here. I'm just walking you guys through. But this is what we were talking about before. 68 out of 102 total is close friends. 24 out of 102 total is acquaintances. You add those probabilities together, and you come up with 92 over 102, which they further reduced to that. Okay. But since these are mutually exclusive, like it's not, well, you can be both a close friend and an acquaintance. No. There's no overlap between close friend and acquaintance. You're either one or the other. Okay. Okay, and then of course there's 10 restricted and they're not part of the solution. All right, let's go on here. Example 3, events that are not mutually exclusive, which is what I was labeling right here. This is where there's some Venn diagram overlap. Right? A game piece is selected at random from the plate right here. What is the probability that the game piece is round or orange? Okay, I see different shape pieces and also different color pieces, and there's some overlap from all the pieces. Okay, so let's see if we can figure this out. We want round or orange. Example 3. Right, so how many pieces are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me double count. 3, 4, 6, 7, 8. Yeah, so there's 10 pieces. Okay. So probability of round is, well, I see 1, 2, 3, 4, 5 round pieces. There are 5 round pieces out of 10 total. Okay. Probability of orange is, well, there's 4 orange pieces out of 10 total. Okay. Now, probability of round and orange, got my intersection symbol for and. This is and right here. Okay. Well, it looks like there's 2 of those. So 2 out of the 10 pieces. So if I said, what's the probability that you draw a piece and it's both round and orange? It'll be 2 out of 10. Okay. But that's not what they asked. They said round or orange. So the probability of round or, so I'll put a union for or, orange. Okay, here's my or symbol right here, or for union or. I can add the individual probabilities together. So round is 5 out of 10, orange is 4 out of 10, but 2 of those are now double counted that are both round and orange. So I have to subtract that out. 2 out of 10. It's 5, 6, 7, 8, 9, minus 2, 7. I think it's 7 out of 10, or 0.70, or 70%. Right now, that's 3 different ways to express the correct answer. So it'd be any of those. Oh yeah, it looks like that's what the book also got. Okay. Okay. So remember, if their events are, where's that card? Oh, there's not mutually exclusive, there's a Venn diagram overlap, you do have to subtract out that intersection so that you are not double counting the probabilities. All right, so quick did 3 main examples. Now, beyond that, I got some highlighted questions here. Let's see, what is number 6? Students. A group of graduate students, the um, 4 out of the 5 females are international students. 2 out of the 3 men are also international students. What is the probability of selecting a graduate student from this group that is male or international? You know what I think would help to do is to draw this out. Draw this out here. Okay, so um, we got 5 women, and then 4 are international women. Okay, we got 3 men, and 2 are international. Two of them. Okay. Uh, this might be a funny looking Venn diagram. Okay. Well, I know if I draw a Venn diagram, like you're not going to be both a woman and a man at the same time. So I think those could be actually mutually exclusive, just the women and the men. Right, so I'm thinking about mutually exclusive for women versus men. Okay. But then there's also this group international, and that's going to have some overlap with both of these. Right, so I think this is what my Venn diagram looks like. Right, so I'll put international as this bubble. Let's put women here. Let's put men here. Okay, let's like that. All right, let's see if we can fill them up. So because we've got 1, 2, 3, 4, 5 spaces to put some numbers. Okay. All right, so 5 women and 4 of those are international. So I think there would only be 1 woman who was not international, and the other 4 are international. So that adds up to my 5 women altogether. Okay. Now on the men's side, there's 3 men altogether, 2 are international, and that makes 1 not. Okay. So I think my Venn diagram has to look like this. Okay. And of course, there's nothing actually, I said 5 spaces, but really there's only 4. There's nothing that would go here because, okay, you got these categories. All right. What was the question again? It said, what was the probability of selecting a graduate student from this group that is male or international? Okay. Male, that word right there, or is key because if they said and, that would be a totally different answer. Maybe I'll do both of them here for you guys. Okay. So probability of man or international equals, right. I know that there's a few ways you can go about this. You could do this probability of man, probability of international minus the intersection. Right. Here, maybe we'll do it first. Probability of man plus probability of international minus probability of man and international, which would look like how many are there altogether? There's 8 altogether. So that's 3 out of 8 are men. 6 out of 8 are international, and 2 out of 8 are international men. So that's 9. Okay. So that'd be 7 out of 8. Okay. Now, another way you could have done this is you could have just added up everything that was either man or international. So 4, 5, 6, 7 out of 8. Right. So I could have said 4 plus 2 plus 1 out of 8 total, which is still 7 over 8. Okay. So a couple of different ways to look at it, perspectives, but you'll get to the same answer. Okay. Now, if they change one word in the premise, the question, if they said probability of man and international, or maybe I'll just do this up here, you would get a different answer. So probability of man and international, that's only talking about these 2 right here. So those 2 out of 8 total. So if you just selected somebody randomly, right? Well, that'd be 2 out of 8, right? Which reduces to 1 out of 4 if you like, or 25%. Right? 7 out of 8. I think it's like 87.5%. Yeah, 7.5%, which is actually what the book asked. All right, so there you go. Okay, here's the question they actually asked down here in the answer, and then it threw in a little bonus question they could have asked. Got all that. Get this back straight. All right. And that was number 6 from your book, page 217. All right, so we got next here. That was one of them. Um, we got lots of card questions, but we did an example of that earlier. The 16, school. Venn diagram shows extracurricular activities enjoyed by senior class at Valley View High School. Okay, so we got drama, band, and athletics. You can be in one group or two groups or all three groups. Looks like there's 10 students who are in all three groups. Or it could be in none of the groups. It looks like there are 67 students who have not joined any group at all. Right? So let's go down to question 6. How many students are in the senior class? Oh, I think we can very simply add up all the numbers. Right? So let's go to it. I've got 38 drama students who are only in drama. Okay. Now there's some drama students who, of course, also in these other activities too. So let's go at these. So we got see 51, oops, so plus 51 strictly band students, plus 137 strictly athletic students, plus 67 not in any group at all, right? Now, what about these intersecting groups? There's 30 in both drama and band that we hadn't accounted for yet, so I just added them right there. There's 8 in band and athletics. There's 4 in athletics and drama. Okay. And finally, there's 10 that's in all three of these groups. Okay, now I got it all together. It looks like 345. So this is number 16A. Right, the sum of the students is 345. 345. Next question. How many students participate in athletics? So back to here. Okay, let's see 137 that are only athletics, but let's not forget these 4 that are athletics drama, these 8 in athletics band, and these 10 that are in all three. Looks like 159. So sum of athletics comes out to, I got 159. Question C, if a student is randomly chosen, what's the probability that the student participates in athletics or drama? Okay. So probability of athletics or drama. Okay. Well, I know one way I could get that. So I could do probability of athletics plus probability of drama, and then subtract out the overlapping section so that I'm not double counting. So I'll say athletics and drama. Right, just to follow this format right here. Right. So let's see. Well, we got some of athletics is 159. So I'll do 159 out of course, 345 students could be in athletics. Okay. Now drama, let's get that number. That's 38 and 4 and 10 and 30. So it's like 82 out of 345 students are taking drama. Okay. But I know I've double counted some students. Athletics and drama, there's these 14. 10 and 4 is 14. So I have to not double count those. Okay. Let's see what I get. What's 159 plus 82 minus 14? So I'm looking at 227 students out of 345. And if you want to make that a decimal, that's 0.658. And as a percentage, 65.8%. So there's 3 different ways to write that answer. Now there's another way you could have gone about this, which is, let me do this other way. I could go back to the Venn diagram. I'm going to answer the same question, athletics or drama. I'm just going to add up every single number of students that lands in any one of these spaces. 1, 2, 3, 4, 5, 6, any of those 6 spaces. So that's 38 plus 30, 10, 4, 8, and 137. Okay, now there's still 345 total. Okay. Let's say they get the same thing. This should be the same thing. Let's see if it is. So it's 38, 30, 10, 4, 8, 137. Yeah. It's exactly the same thing. Exactly the same thing. Okay. Okay, so whether you're counting this bubble and then this bubble individually and then subtracting where they overlap, which is what I did first and boxed in here. Or if you just count up all the spaces and you only ever count everybody once, which is what I did here. Either way, you get the exact same answer. Okay. And question D, if a student is randomly chosen, what is the probability the student participates in only drama and band? Okay. Now the word and means I'm looking at the intersection. It's not, well, drama or band. No, it's not or, it's and. So you have to do both. So where's drama and band? Well, that's these 30 that are in drama and band. I'm also going to include these 10 that are drama, band, and also athletics because there's nothing wrong with being in athletics. We just want you to make sure that you're in drama and also in band. And so probability of drama and band. So this is 16D. Okay. Is okay, these 30 plus these 10. And remember, there were 345 students total. We figured that out. Okay. So I could say 40 out of 345. That should be the answer. Now this I know I could reduce, or we just turn this into a decimal. Right. 0.116 or 11.6%. Okay, so there you go. Just 3 different ways to write that answer. Okay. Okay, let me go ahead and reduce this while I'm at it. Okay. Because if this were an Alex question and they wanted the fraction answer, they probably want you to reduce this. Now, I do see that both these numbers, the numerator and denominator, are divisible by 5. So let me go ahead and do that. So I'm going to say divide by 5, divide by 5. So it's 8 over, that's 345 on 5, 69. Okay, yeah, that looks reduced. Yeah. So there's 1, 2, 3, 4 different ways to write the answer. All same thing. Let's do one more here. One more. Number 25. Oh, you rolled 3 dice. Okay, well, I got some dice here for a visual, so that's nice. What's the probability that the outcome of at least 2 of the dice will be less than or equal to 4? Explain your reasoning. The outcome of at least 2 of the dice. All right, so this one I think is a little tricky, and I had to work this one out ahead of time. I'm gonna write this down. Okay, so 3 dice. Okay. We're looking for a probability that 2 of the dice show. It says less than or equal to 4, so I'll spell that out as 1, 2, 3, 4, 4. Okay. And the way I figured to put this together is that we can look at each die individually. So I'll do die, maybe I'll call it die A, die B, and die C, right? So I'm not throwing more numbers in the mix, so I'll just call them A, B, and C. So maybe like this die, and this die, right? Something like this, right? Now, and I think what I can do is just very simply go through each scenario and look at the probability and then add up all the probabilities. Okay, so what if I want this die to be 4 less and this die to be 4 less? And well, it says at least 2, so maybe this one will have is not the case or something, right? So I'll make this one 4 less, I'll make this one 4 less, and I'll make this one not the qualifying, right? Now what's the chance that exactly something like that happens? Well, this one being 4 less, that'll happen 4 out of 6 times, which I can reduce to 2 out of 3. Here, maybe I'll just spell it out as 4 over 6. And if you want to reduce that to 2 over 3, you can. That's also true for this one, would be 4 out of 6. Okay. Now for this one to be either a 5 or a 6, which would be not be disqualification, that's going to happen 2 out of 6 times because it could be a 5 or it could be a 6. Okay. Now for that to happen exactly, so I roll this, and I roll this, and it plays out exactly like that. I could multiply all those together. Okay, let's see what that is. That's 4 times 4 is 16 times 2 is 32 out of, then 6 to the power of 3 is 216. Okay. Now you could reduce this. So what if I think each of these are divisible by 8. 32 over 8 is 4. 216 over 8 is 27. Okay, yeah, so that does reduce to that. Okay. Now this is only one scenario. So what about this? What if I roll the first die and it comes out to 1, 2, 3, or 4, which happens 4 out of 6 times. The second die, comes up as either a 5 or a 6, which would be 2 out of 6 options. Let's say the third die actually does come out to either 1, 2, 3, or 4, which is also 4 out of 6. Okay. And if you think about it, this is just the same fractions but rearranged. So it's going to be the same probability of this particular scenario playing out, which is 32 out of 216, which reduces to 4 out of 27. Okay. All right. So here's the first two showing up as 1, 2, 3, 4. Here's the first and third showing up as 1, 2, 3, 4. Right, and of course not the third one. Okay. Now you could have, how about the scenario where these two show up as a 1, 2, 3, or 4, and this one doesn't. So that would be 2 out of 6 on this guy, times 4 out of 6 on this guy, times 4 out of 6 on this guy. Okay. Which would be it's the same numbers. 32 out of 216, which reduces to 4 out of 27. Right. Now there is a scenario that I haven't talked about yet, which is what if all three of these dice are qualifying? Because it just says, oh, whoops. Right, I gotta add a little condition here. At least that changes the premise a little bit because I still have another scenario to consider. At least two. Right? It could be all three. Right? As soon as I add that at least in there, which and the book said, and that's going to happen 4 out of 6 times here, 4 out of 6 times here, 4 out of 6 times here, which looks like the previous fractions except double. So I think that has to come out to 64 out of 216, which reduced to 8 out of 27. Right. So I could roll all three of these dice. Right, just do a random roll, line them up. Right, you guys saw that was a random roll. Let's see. This is doesn't qualify, does and does. So, bing, bing. That looks like this one right here. What was the chance that something similar to that happened? Well, that would be 4 out of 27. Let's roll it again. Do a random roll. Right. So I got die 1, 2, 3. Right. So now this one passes bing, and then fail and fail, which I don't have listed here because it does not match this condition. Right. So it would be part of the not condition. Right. Now I've counted up all these individual scenarios, and these are all mutually exclusive. Right? So if I consider die A, die B, die C, right, they can't like overlap. Right. Right. So I think to get the probability total for this question, all I have to do is add up all these individual probabilities. It's 8, 8, 16, 17, 20. So that's 20 out of 27. And if you reduce this on a calculator or find a decimal, I'll show you guys what's 20 out of 27. Right? It's approximately 0.74 or 74%. Right? Not exactly, but pretty dang close, about 74%. Right? If you flat here with these three dice, so you just roll them like 100 times, I bet really close to 74 times, probably somewhere between 70 and 80 times, you would get this condition where 2 out of 3 dice or 3 out of 3 dice were 1, 2, 3, or 4. All right, so that was a little trickier to think about, but that's a good one to end on. 10-5.